Okay, so let's consider the first theorem of convergence. If the sigma from n is equal to 1 to infinity for an, the general term an, is convergent, then the limit n approaches to infinity an has to be 0. Okay, so let's think about why this is so. First, recall that from sequence and series, right, that an is simply Sn minus Sn minus 1. Okay. Now, we're given that this is convergent, meaning, right, Sn, as n approaches to infinity, is approaching a particular constant. But then, what about Sn minus 1, right? This is going to be approaching also C, maybe a little bit less or a little bit more, right? So right, a little bit less, a little bit more, but essentially the same, right? So you can see the idea here. An then, right, essentially is that limit, the convergent number, C minus C, right? If you replace that there and that there. So of course it's not exactly the same, right? We're assuming it's the same if we can make it as close as we want the further we take it down to this C, right? So that means we can make this as close as we want to 0. Okay, so that means the limit of this is 0 as n approaches to infinity. Okay, conversely, so this is true. Conversely though, what happens if n approaches to infinity for an, right, does not equal to 0? So you add up to some particular constant, or even worse, infinity. What happens to this then? Right. So let's say the limit of this infinity is approaching a particular constant. That means whatever happens from 1 to a very large number, right? After a very large number, so at a certain point, we're going to be constantly adding C and C and C and C, right? So it's going to constantly increase if C is positive, and it's going to constantly decrease if C is negative. That means this is definitely diverging, right? It's not going to converge to number. It's going to constantly increase. The sum is going to constantly increase. Okay, so this is actually more important to determine for most of the questions that we'll be doing whether a particular series infinite series is diverging. Okay, so if the number in front, the general term of the infinite sum is does not equal to 0, then it's divergent. We can conclude that it's divergent.